Hi guys, in this video we're going to talk about proving angles congruent by using addition and subtraction. We're going into introductory proofs. Proofs are one of those things that are a very important life skill, but are very difficult for students to learn of all ages, including myself. So hopefully you guys will find this video helpful. Okay, let's talk about what proving is. All proving is a series of steps or statements that are backed up by justification to lead to a conclusion. So, very similar in nature to an argumentative essay that's referenced or has links to it to other literature, research-based documents for those of us older students. What we want to do is we want to form a conclusion and back it up by a series of facts. In my opinion, this is a critical life skill. It requires a lot of thinking in the front before you can perform any action. So let me show you a very simple example using a process that most students are familiar with at this point, which is to solve equations. So I'm going to simulate a proof by solving this equation. I'm going to start with my opening statement, which is usually what is given to me. So I'm going to start here by saying 4x plus 3 equals 15 is given. Now what I want to do is go through the process of solving this equation. So I'm going to do that first. So I'm going to subtract this 3. And therefore I'm going to get 4x equals 12. Then I'm going to divide this 4 and x equals 3. The important part of this proving process is backing up every statement I make with a reason. Okay, so I purposely inserted some lines crossing out the arithmetic step. The reason for that is when we prove, even in algebraic proofs, typically the step is not written, but instead justified. So I'm going to write down the justification or the reason for taking this step. In this case, I subtracted 3 to go from 4x plus 3 equals 15 to 4x equals 12. So I'm just going to call this the property of subtraction. Then I went from 4x equals 12 to x equals 3 by dividing the 4, which undoes the multiplication. So I'm going to call that a property of division. The purpose of this exercise is just to show you that you can back up every statement that you make or every action that you make with a fact or a reason. Oftentimes, the reasons themselves, just like in any kind of form of literature or essay or research, can be argued. So there is definitely a number of different reasons that could have been written here to justify the steps I make. So now, let's take a look at a couple of definitions that will give me more tools to do some proving. I'm going to do my best to write into these little boxes. So let's take a look at the complementary angles. The definition of complementary angles is when two angles are put together or added together to equal 90 degrees. So here's how we can write that. In a very simplistic fashion, I can write here angle 1 and angle 2 are 90 degrees. So I could justify that reason by stating are a property of complementary angles. Okay, let's take a look at a linear pair or supplementary angles. So here, these are two angles that will equal 180 degrees. So I could just say that angle 1 and angle 2 are 180 degrees. There are quite a number of statements here I can make when I see a linear pair or supplementary angles. But in this case, for the purpose of our proofs that we're going to cover here, I'm going to make these statements. And I could justify them by just saying either I see a linear pair or I see supplemental angles. The reason is justified by the type of angles you were given. Let's take a look at how we use the addition property to progress our proof. So, I could go from knowing that I have supplementary angles or stating that I have a linear pair to saying that I could add them together to equal 180 degrees. I understand if you're looking at this appears to be like splitting hairs. And the answer is kind of yes, but we want to justify every step with precision, and as much precision as possible to alleviate having holes in our argument. This is why I make the statement that these are such huge life skills. So I could justify this by saying that angle 1 plus angle 2 equals 180 degrees by employing a property of addition or using the addition property. However you want to write that. You're making clear what steps you're taking by speaking them. Let's take a look at the transitive property loosely here. We're going to really dive into that in the next example. So I didn't really give myself room to write out the transitive property. It's usually 2 or 3 lines, and it starts with this statement here. Here's what happens. If I have 2 expressions that I could set equal to each other, then I have 2 of the same elements, like in this case, this angle 3, I can make the statement that because that angle 3 is on both sides, that means angle 1 and angle 2 have to be equal. It's the same properties that I am using when I solved this equation earlier. I'm making the statement here that x equals 3 because I was able to remove all the other elements when I had 4x plus 3 equals 15. Coming to here, if I take out the angles 3's, that means angle 1 and angle 2 have to be the same. Alright, let's look at an example. Okay, let's look at a formal proof. So, typically, when we do proofs, we really have to come up with a strategy way before we even start writing the proof out. But, what I like to get out of the way while I'm kind of marinating on the proof, I like to just write down the given. So, I literally copy the given word for word. It is really kind of critical here. Don't summarize the given or remove some language from the given. Do your very best to copy the given down word for word as it is provided, because oftentimes there are little details, definitely as we get to advanced proofs, that will really help us get to our conclusion. So let's come up with so what I'm going to do here is I am going to introduce an angle. Just as we saw when we covered the transitive property, I'm going to introduce an angle here. I could have introduced that angle here as well, but it doesn't really matter, so I just chose to introduce it there. As a beginner, I would really use those top definitions and try to create that situation when you can. Depending on the formality level of the proof, just like a written essay, you may have to actually make the statement, or it may be expected of you to make that statement that I am introducing angle 3. I'm not going to do that here. I want to try to keep this process as basic as possible so you can get the foundational skills of proving. So what I notice in this proof, I have two sets of linear pairs. Angle 1 and angle 3 are a linear pair. Angle 3 and angle 2 are a linear pair. Both those pairs will equal 180. So then I can say that angle 1 plus angle 3 will equal 180. Angle 3 plus angle 2 will also equal 180. So I can then employ the transitive property. It's very important when getting control of proofs that you just take a few seconds to come up with this strategy. So now that I've come up with a strategy, I'm starting to fill out my table. I made the statement that angle 1 and angle 3 are 180 degrees because that is a property of them being a linear pair. I've done the same with angle 2 and angle 3. I want to pause and point out there are a number of statements I could have made here that will get me to my conclusion. I'm trying to present these proofs as straightforward as I possibly can while maintaining the formality of them. So, my next step from here is to use or employ the addition property. I've added in the statements for the addition property. You may be saying to yourself right now, it looks like I'm saying the same thing twice. And I kind of am, but kind of not. So let's break this down. The first statement I made is that I recognize that angle 1 and angle 3 are 180 degrees because I recognized a linear pair. And then I noticed that angle 2 and angle 3 do the same thing because I recognized the linear pair there. The next two lines are stating what I am doing with that information. I am making clear that since I recognized the linear pairs, I am now going to add those angles together so that they equal 180 degrees. If I didn't do that, the question would be, how do you know that angle 1 and angle 3 are 180 degrees? So I am very discreetly and precisely trying to line out every step of my argument, so therefore there's no questioning. Also, somebody looking from the outside in understands every intricate step I made. Now, let's employ the transitive property. So, I employed the transitive property by substituting one of the 180 degrees with the expression. So, instead of having here written angle 1 plus angle 3 equals 180 degrees, I replaced that with angle 1 plus angle 3 equals angle 2 plus angle 3. And one of the things I've managed to do was get this angle 3 here and here on both sides. So now what I can do is I can take those angle 3's away because they're both the same angle and make the statement that angle 1 and angle 2 are equal, proving why vertical angles are always the same. So let's take a look at that. So now what I did is I subtracted the angle 3 out. Recall in my very first example that I drew the lines through the arithmetic steps? Well, this is what it formally looks like. Because I had angle 3's on both sides of the equal signs, I was able to subtract them out from both sides, leaving angle 1 and angle 2 equal to each other. One other point I want to bring up before we move on to the next two examples. This concept of the transitive property. It honestly depends on where you look for proofs. Some proofs will name this the substitution property, and I've done that plenty. There is a minor difference between substitution and transitive, and substitution occurs when you only replace one term. Transitive occurs when you replace an expression. What happens here is you're at the mercy of the person that is teaching you the proofs and what their expectations are. So, knowing that, I chose, with a lot of deliberation with myself, to say we're going to call this the transitive property. Alright, let's take a look at two more examples. Okay, so this is actually a very classic proof that is often covered when we're talking about proof. But the proof is very similar in nature to the proof we just did, just I don't have the luxury of numbering angles here. So, here we go. Here's the strategy for proving that AB is congruent to CD. Or, in other words, I really haven't talked about this yet, that AB is the same as CD. So the difference between equality and congruency is, one is talking about a numerical concept. So 4 equals 4, or 4 equals 2 plus 2. AB is congruent to CD is stating that they are physically identical in every way. That's the difference between equality and congruency. Alright, let's look at the strategy here. So what I could do is I can add AB and BC together. I can also add CD and BC together. Then what I could do is remove this BC here, forcing AB and CD to be the same. So let's take a look. So I followed through on my steps and I wrote my information into my lines. I'm using the addition property as directly as I can and just stating addition property of segments because AB and BC are parts of a line or line segments. If you were to look this proof up, you will see the segment addition property. In my view, this and that are saying the same exact thing. The only difference is we don't need to create a different reason. We could just combine reasons. This statement justifies very clearly why I am stating that AB plus BC equals AC. Alright, now I'm going to employ the transitive property again. Okay, so I employed the transitive property by replacing AC with CD plus BC. I was able to do that because I was told from the start that AC is congruent to BD. That means we can swap them. So a point I should bring up here is that it's very important to take the time to understand that information that's being given to you. These are more like thought experiments. You have to know where you're starting. Okay, so now, just like the previous proof, I'm just going to subtract that BC. Okay, so now I subtracted the BCs on both sides. So I now have AB is equal to CD. I have one more step to make. That's a serious formality. I'm throwing it in there so you can see it. So I wrote one last line that just states that AB is congruent to CD. So, like we talked about in the start, equality talks about a numerical value, congruency talks about a physical value. So you kind of want to make that distinction depending on the formality of the proof. If you notice, on the previous example, I didn't do that. So I often forget to do it too. It's not a big deal to me, but could be to others, so I just wanted to present that. I should put one other warning out there for this proof. I have seen this proof proved in different ways in way more complicated fashions with way more intricate steps. I am showing you again the basic proof, the most basic example of these proofs, so that you can, as a beginner, get the basic idea down and the process down for creating these arguments. Okay, let's take a look at the last example. So the first thing I want to show you is the given. I chose to, in this circumstance, to write the given in 2 lines because I'm clearly struggling with this pen to write into these tables. I could have written this given statements into 1 line if I had the room. But here's the important part. If I choose to do that, I have to state in both lines that the reason why I'm making those statements is because of the same reason. That's why you see given written twice. In other words, just as I mentioned earlier, I can make statements, different statements, supported by the same reason. I could also make the same statements supported by different reasons. So you have to make that clear. I can say twice in a row that I'm making different statements by employing the addition property. We've seen that through this entire presentation. But I have to make that statement twice. I am doing this again. I'm making that clear that I'm repeating the same steps as I did before. Okay, now what I'm going to do is come up with a strategy to get to my point. Well, when I read the given is telling me that angle 1 and angle 2 are supplemental. That means when combined or added together, those 2 angles will equal 180. I could also make the statement that angle 1 is congruent to angle 3. So that means if those 2 angles are the same, I can also make the statement that angle 3 and angle 2 will equal 180 degrees. From there, I should be able to employ the transitive property and subtract my repeated angle. So let's take a look at how this writes out. Okay, I started the same way as we have before. Knowing that my angles are supplemental, I make the statement that I recognize, because they're supplemental, that angle 1 and angle 2 are 180 degrees. Then I'm stating clearly how I'm going to use that information by saying angle 1 plus angle 2 equals 180 degrees. Now what I realized is that my strategy was really not a good one. I could just simplify this by saying that I could substitute angle 1 with angle 3 because they are congruent. So I'm going to do that. Okay, so what I chose to do was substitute angle 1 for angle 3. I was able to do that because of this statement. So, I now pretty much have my proof. Keep in mind, I didn't do this on purpose. Keep in mind, you come up with a strategy and you move forward. But, just like in real life, just like in true problem solving, you could change that strategy as you move forward. As different facts become clear, or as you recognize different details, you can make minor adjustments. So, now all I have to do is make my final statement. Okay, so Just like with the given, which I stated earlier, you cannot or do not want to abbreviate and summarize. I also wrote the conclusion or the proven statement at the bottom in verbatim. That's very important. Now for my reason. Well, I know that a property of supplemental angles is that they will add to 180 degrees. So I can back up my conclusion with this statement here. I personally like to add this statement here, which is from the previous line, which backs up what I'm saying. There is no arguing in my conclusion that I have recognized a property of supplemental angles through the addition property with the way I wrote that reason. Okay, guys, in conclusion, I know if you have not done any proving in the past that this is very daunting, and I respect you 100%, but I encourage you to take on this challenge, because when you do, it creates a different mindset of problem solving and communicating. But recognize, in changing that mindset, it's going to take quite a while. Hopefully, you guys found this video helpful.